So today we're going to be adding and subtracting polynomials. Essentially, all we're doing is combining like terms, but now we're seeing them as polynomials. They're usually going to separate and put a polynomial in a parentheses. The biggest challenge will be when we subtract, and we're going to do a little trick called keep, flip, change, or stay, change, change. Whatever you learned for integers, we're going to sort of apply those to polynomials. So here is a quick little warm-up, and this is just combining like terms, which we did back in chapter 1. So here, you're just going to add 4x plus 2x, and you get 6x. You're just adding or subtracting the coefficients. The variables are going to stay the same, okay? In order for you to add like terms, it has to have exactly the same letter and exactly the same exponent. So look at example 4 here. Notice one is the 5n and the other term is a 6n squared. Those are not like terms, so that would be the simplified answer. You can't simplify anything else. Then 5 through 7, we're just applying distributive property. So you're going to distribute the 3 to both the x and the 4 and get 3x plus 12. You lost? You need help? Oh. Combine like terms, they have to have the same letter. When you multiply or use distributive property, you can multiply a letter and a number. So for example, on number 5, where they distributed the 3 to the x and the 4, we can actually multiply this, and then you just leave it apart. The 12 doesn't have an x, so that's as simplified as you can get it. What? So our objective here is to be adding and subtracting polynomials. And just as you can perform operations on numbers, we can perform operations on polynomials. So today we will add and subtract. Coming up later on next week, we will be multiplying polynomials. And then after that, we will be dividing polynomials. So essentially, all we're doing with the adding and subtracting is combining like terms. So here is our first polynomial. Now, notice the directions say add or subtract. Depending on the sign that's in front of the number, sometimes we may be adding, sometimes we may be subtracting. So in example A here, the only like terms that I have that I can group are going to be the 12p to the third and the 8p to the third. Notice they've turned them into red, and then they're going to group them. I don't need to see you group them next to each other, as long as you can realize that I'm grouping these two together, and 12 plus 8 is 20. Now, when we're simplifying polynomials like this, or adding and subtracting, we're not using inverse operations. All we're using is the sign that's directly in front of the number. So in this case, this was an addition sign. So I'm adding 12 plus 8, and I get 20. I'm not adding exponents here. The variable will stay exactly the same way that it is. We're just combining the coefficients. Yes, question?
Okay, so what if one of them is addition and one is subtraction?
Okay, so like for example on part B here, notice this 6 has a negative sign in front, and this has an 8 in front, positive 8. So when I go to group those, I'm doing negative 6 plus 8. So whatever sign is in front, so when the signs are different, when one's a subtraction and one's an addition, we're going to subtract and keep the sign of the bigger number. Does that make sense?
Okay.
All right, so we're grouping our like terms. So when I go to group this, I'm pulling the negative 6 out and the positive 8. So think of these as signs on the numbers instead of adding and subtracting. Does that make sense? So here, only thing I could group were the numbers on part B. The 5x squared, there was nothing else with an x squared, so I just rewrite that number. Same thing with the 3x. There is nothing else to group with it, so I just rewrite negative 3x in my answer. And then the two that I could actually group were the -6 and the +8, giving me a +2. Let's look at another example. So in this case, let's go through and let's find all of our like terms. We have a t squared here, and I have a t squared here. Notice when I go to highlight this, I'm pulling the sign also. So when I go to do this, I'm going to be adding t squared minus 4t squared. Yes?
So do the exponents have to be the same too, or just the variable?
Yes, no. Everything has to be the same. So the letter and the exponent in order to group them. So I can't group an x with an x squared. Those would be unlike terms. So here I'm going to first group the t's, and then I'm also going to go and group my s squareds. And notice you're going to pull the sign. So for the s squareds, you would do the problem 2s squared minus s squared. And I'm assuming a 1 in front of that. So for the red, for the t's, you're going to do 1 minus 4, and this gives you -3t squared. For the blues, this becomes 2 minus 1, so this just becomes 1s squared. And again, in your answer, when you write it, you don't have to put the 1. Good so far? All right, next. Now, like terms could be constants or terms with the same variable raised to the same power. So, for example, if I wanted to have something like x squared plus 2x minus 4, there's nothing here that's like, so that would be my answer. But if I had a plus 2x squared, I could actually combine this and this. It has to have the same letter and the same exponent to group it. So this would become 3x squared plus 2x minus 4. And that's your simplified answer. Here's another example. Yes?
You also add exponents or
No. We keep the letter and the exponent exactly the same. When we multiply, that's when we're going to be adding exponents. You are not adding exponents here. We're only adding or subtracting coefficients. So for part A here, the only thing we can group together is going to be the s squareds. So I can add 2s squared plus 3s squared and turn it into 5s squared. The s over here does not have an exponent, so it's all by itself. It doesn't have any like terms to group it with. So the only ones I could have grouped were the red ones, and then I would leave the s by himself. The next one, I can group all of my z to the 4th powers, and then I can group my constants. And then you end up with 20z to the 4th when you add 4 plus 16. And then when you group the -8 plus 2, that gives you -6. Good on that? Yes.
May I use the restroom?
Yes. Okay. Next, we're going to still do some more practice. Notice all of these are, let's see, what can we group here?
the y's?
Just the y's. Look at this x. He's all by himself. So the x doesn't have any, oh, there's another one here. So the 2 x's and the 2 y's.
My QR code isn't.
Problem, you would just group your x's. So 2x to the 8th minus 1x to the 8th just gives you an x to the 8th. And then when you group your y's, 7y to the 8th minus 1y to the 8th gives you 6y to the 8th. And you leave it apart. So when there's no parentheses or anything, all you're doing is going through and combining like terms. And we did this way back in chapter 1. All right, now, when you go to add 2 polynomials, they're generally going to be given to you like this, with one in one parenthesis and then the other one. Probably in the homework when you first practice, they might give them to you vertically. So for this method, you would just take all of your like terms, like all your x squareds, line them on top of each other, all the x's and all the ones. Adding the polynomials, essentially what you could do, if you're going to do them horizontally, you could just drop the parentheses and then just look for all the x squareds, put them together, all the x's and all the constants. Or you can line them up vertically. I don't care which way you do it. I don't need to see you regroup them and put the x squareds in a parenthesis, the x's and the numbers. But just be careful with your signs. So for example, if this were your problem, let's look at A. So essentially, if you want, you can drop your parentheses. And now go back, since you're using your iPad, you could color code them, circle all the m squareds, then go back, circle all your m's, and then go back and circle all your constants. So then now go through and combine your like terms. So for the blue ones, the m squareds, I would get 4m squared plus 1m squared, and that would become 5m squared. There was nothing else that I circled in red, so I just rewrite the negative m. And then I can just drop the parentheses and group your like terms. Here's another example. Again, you could drop your parentheses and then go back through, find all the x squareds, highlight them or circle them. Now there are 3 of them here that I could group. So I would add 6 plus 3 minus 8 and then just get 1x squared. Then go back, get all your y's. I've got a negative 4, a positive 3, and a negative 2. So negative 4 plus 3 is negative 1, minus 2 is negative 3. Okay, the hardest part here is going to be just taking your time and watching your signs. Again, here's some fractions. Again, I don't know if there'll be fractions on the test yet or not. I will let you know on Thursday. Let me get to a subtraction one. So here we go with the subtraction. Now, remember, when you subtract integers or polynomials, remember subtracting is the same thing as adding the opposite. So what I like to do is I like to do what I call keep, flip, change or stay, change, change to the polynomial. So for example, when I'm asked to subtract this first polynomial and subtract the second one, what I do is I take the first one, I keep it the same, so it stays, or I keep it. Then I change the subtraction sign that's in between the 2 polynomials, and I make it an addition sign. And then everything that's in the second parenthesis, I make it an opposite sign. So for this one, it was pretty basic, and you could see what to subtract. So x to the third plus 4y in the parentheses minus 2x to the third. So I'm going to keep my first polynomial the same. I'm going to change this subtraction sign to addition, and then I'm going to flip the sign of my second polynomial. And now I go through and combine like terms. So this is now going to be these 2 that I can group, and I get negative 1x to the third plus 4y. Let me do another one where there's more terms in the polynomial. So again, I'm going to keep, flip, change here. So I'm going to keep the first one the same. I'm going to change this subtraction sign to an addition. And then in the second parenthesis, everything goes to opposite signs. So the first one becomes negative, second positive, and then the last negative. Now I go through and combine like terms. So I have m to the fourth right here, and then another m to the fourth. So when I group those, I get 2m to the fourth. Now I'm going to go through and grab my m squareds. So I have a -2 here and a +5 here. So this becomes plus 3m squared. Nothing to group with the -8, so I just write it right there. So as long as you do the keep, flip, change, then it just turns into combining like terms. Let's look at another example. Again, I'm going to keep the first one the same. So -10x squared minus 3x plus 7. That keeps. Okay? Then the next thing I'm going to do is change the subtraction sign to addition, and then change the second polynomial, flip all of the signs. Now I'm going to go back, add my x squareds, and this gives me -11x squared. Go back, grab all the x's, because I want it in standard form. And then I put -3x, because nothing to group with it. And then lastly, get all the constants. So 7 plus 9, and that gives me 16. And that is my simplified polynomial that I just subtracted. Another example, keep this one the same, change this to addition, and flip these to opposite signs, and then combine like terms. Same thing here, keep, flip, change, combine your like terms. Notice here, when you went to combine your ones, it canceled away. You don't have to put +0. Here's a word problem. Here it says a farmer must add the areas of 2 plots of land to determine the amount of seed to plant. So here the area of plot A can be represented by this equation. The area of plot B by this equation or expression. It says write a polynomial that represents the total area of both plots of land. So all they want you to do is add these two polynomials. They did it vertically. They lined up everything. They put the x squareds on top of each other, the x's, and then the numbers. And then the whole total area would be the 8x squared plus 3x plus 6. One more word problem. Here, they've got 2 manufacturing plants, and they want to know the total profits from both. So they took the eastern and they added it to the southern. And then this would be the total combined profit. Again, we're not solving for any variables. We're just grouping our like terms and adding the polynomials. And here's a few examples. So your homework tonight is practice A. Then tomorrow we'll practice this a little bit more. And then on Thursday we will review for your test. The study guides are already up and published, so you can start looking at them. And then Friday will be your last test of the quarter. Any questions?